Hey everybody, so let's take a look at lighting in Max. I've set up a little world here, a standard jit.world with a handle and a reset connected. One thing that's new is I've added the erase color attribute. That allows me to set the background color of my world to black or red, whatever I want. Here I've set up a camera with some buttons so I can have different views. I have a side view, a top view, a front view, and a medium close-up. And I also have the position attribute here, which is I'm just using as a display to show me which camera position I'm in. I can also adjust it from there, but then I can reset it. And these are message boxes that I'm using as buttons. So when I click the message box, it sends the three messages that are contained in it. First, it sends the position message, then it sends the look at message, then it sends the tripod message. These are separated by commas, so they send in order. And that's a very useful thing that you'll do a lot in Max. So let's add a model here. I have this drag into my patch, and there she is. I'm going to give her at material mode 0 so that I can give her a color using the jit.gl.material with a at color 1111, which is white. And the fourth one means opaque, means no transparency. We'll talk more about that later. And give a specular model of Cook Torrance. Connect that. And she's in kind of a weird pose because she's an animated model, and we're going to work more with animated models later, but I thought I'd just use an animated model for this tutorial for fun. So I'll send the anim enable message. And the anim enable message takes two arguments. The first is which animation I want to enable or disable, and the second is whether I'm enabling it or disabling it. So 1 means to enable. So I'm enabling animation number 0, and the 1 means true. Yes, I am enabling it. I'm not disabling it. And there she is in an idle animation. And we can see some of these other animations. If I disable animation 0, she goes back to this weird pose, and then I'll turn on another animation like animation number 2. So animation number 2 on, and that's the running animation. And there's a bunch of animations in her that you can explore. You just got to make sure that you turn off animations before you turn on the next one. Otherwise, the animations will mix. I've turned off all the other animations, taking her back to this neutral pose, and then I'm going to enable animation 0, which is this idle pose, and that's what we'll use for this. And since I want this animation to be enabled every time my patch starts, I'll use our familiar load bang, which will just send a button press, a bang, to this message, which will send the message to the model every time our patch loads. And let's set up a background. We're going to use this curved background that I made in Houdini, and let's take this and encapsulate it. Call it P model. Command J will resize it. And this is a curved background that we'll use as a backdrop for her. Now, one of the things that Max does is it automatically normalizes models when they come in. So no matter how large a model is, it will always be brought down to a maximum size of 1 meter. And that's called normalizing. There's a lot of things called normalize, and you'll be discovering that throughout the class. We use that word in a lot of different ways. But one of the ways in which we use the word normalize is to scale down to a maximum value of 1. So we want to turn that off by saying normalize 0, meaning normalize off. And we can see that this thing is actually much bigger. So I'm going to move that down So I'm going to move that down by doing position -1, 0. And also we see that I built it backwards. So the backdrop portion is actually facing us. So I'm just going to rotate that model with rotate X, Y, Z, rotate it 180 degrees on the Y-axis so it turns around, and now she's standing on this background. So we can give this background some texture. We'll give it this concrete bunker texture here. Plug that into the material. Send the image in with a button. And we've got this concrete background. And now we'll go and look at this from the side, from the top, from the front, in our medium close-up, and try to determine if she's actually standing. Yep, she's standing on it, because we can actually see her feet directly level with that surface. Oh, and our animation must have stopped when we encapsulated this, so we'll create that anim enable again. And one of the things that you might notice is that our texture here is too big, right? This is not a realistic looking concrete because it's just too large. We can't see the blocks. So what we can do is we can tile a texture. And by tile a texture, I mean basically shrink it and repeat it. And we do that using an object, a new object called jit.rota. And it's called rota because one of the things it does is rotate. Stick a jit.rota in there and make a couple of attributes. And to tile, the attributes we're going to want to mess with here are bound mode, zoom X, and zoom Y. And the tiling bound mode is bound mode 2. That means as the image shrinks, it will repeat. But note that as I adjust this, nothing happens until I hit the button again. Why is that? Well, that's because these jit.objects only process imagery when they receive imagery. So they only will process this zoom change when I send the image in again. So even when I find values I like that's pretty good. And you can see what the difference is. Here's the original where it's at full size, filling the entire background with a single image. And here at 0.25, it's 1/4 the size. So we're using 4 of these to fill the entire image. And we have to hit this button a lot, and that's inconvenient. So here's something we can do. And actually, we're going to do this for a number of reasons later on. This is the first reason why we're going to do it. We're going to use the F key to create a floating point number box. And instead of manipulating this box, we're going to be manipulating this box, which does the same thing, except we can hook this up to the button so that every time this number changes, it also clicks the button. So now we're getting interactive changes. And we can do the same thing for zoom Y. We can get interactive image changing. And I'm sure you can see a lot of possibilities for animation here too. This is pretty powerful. But right now we're just using it so we can see our adjustments. So here's the thing I like to do, just so I remember to manipulate the right one, is I take this and I actually put it over the attribute. That way I'm always clicking on the right number box, the interactive number box. So underneath is the attributes interface, but I've used this number box on top of the attributes interface. And this is an idea that we're going to come back to more and more in Max, which is the notion of building control panels. And we're not going to go into depth to it here because our goal here is to work with lighting. So let's add a couple more textures to this. Now that we have values that we like, we'll transform changed attributes to arguments. Command J will size that so that it fits in the window. And we can bring in our normals, our ambient occlusion, and our height map. And one thing you may have discovered on your own is if you don't like how big these images are, because you don't really need to see that much image, you can shrink these down. That's our ambient occlusion. That's our normals. That's our height map. And it's handy to remember that the ones we typically use are every other inlet of the jit.gl.material. And of course, if we're going to tile our albedo, we need to tile the rest as well. So we can option click and drag to copy. And then here's a new trick. Hold down Shift to insert into a patch cord. Option click, drag to copy. Release option, hold down Shift to insert. Option click, drag to copy. Release option, hold down Shift to insert. And now, when I click this, I've got my fully textured back wall there. This is, of course, a big mess, so I'm going to highlight it all, encapsulate it, call it wall, dive in to the wall, tidy up a little bit, and add a load bang so that this will automatically load every time my patch loads. And you can double click a load bang to simulate that. I mean, certainly you can click the bang button too, but if you don't have a button there, you can double click the load bang to load all your textures simultaneously. Let's reset our handle and look at our different views here. And now this is taking up a lot of screen landscape too. Is there a better way to build that interface? Sure. We can connect buttons to these. Take our labels. Command Y will line them all up. And we can encapsulate this. And we'll call this the CCU, or the camera control unit. Get rid of this attribute, and that's a lot more compact setup. The other nice thing about this is we can take these buttons and hook them all to our reset button so that in case we forget, this will always reset our handle every time we switch to a new view. Side view, top view, front view, medium close-up. And one other thing is, if we want to, we can hide these patch cables. We can hold down the Option key to select the patch cables and hit Command K, and that will hide the patch cables on lock. So they're still there, but when we lock our patch, they're hidden just so they're not in our way. So we haven't even built a light yet. So let's go ahead and build a light. There is some light here, obviously, and that's just the default lighting that Max sets up for us because we haven't specified any other light. So let's make a light. jit.gl.light. And immediately we see things have changed in our world. Let's put an attribute and select our type of light. And by default, it selects a directional light, which is the first light I want to look at. So a directional light is like sunlight. It doesn't come from a specific point. It just comes in a particular direction. So that's our next thing to choose here, is the direction that that light is coming from. So right now, the -1 here means it's coming from the right towards the left. The -1 here in the Y means it's coming from the top towards the bottom. And the -1 here means it's coming from the front towards the back, meaning it's like where you might expect a sun to be. It's coming somewhat frontally, somewhat from the right, and somewhat from above. And of course, these are all adjustable. So if we want it to be coming from the front, that will make the light more frontal. And that will make the light more to the left. And you can see how this is affecting the image. And one of the things that makes lighting much more effective is to add shadows. So let's do @shadows 1. Let's zoom out. You can see it's a pretty subtle shadow, but there's her shadow. And if I bring the light down, you see her shadow moves more behind her. And you can already start to get some kind of dramatic effects. It's less like sunlight now because it's not coming from as high, so it's more like a light shining from another room, for instance. And of course, the light does not need to be as frontal. The light can be directly from the side. And then we get some really this is like a cave-like effect. Or the light could be directly from the top. That's a useful light. It's got two colors. It's got its specular color and its diffuse color. So diffuse color and specular color. This wall is giving too much specular reflection. So since this is concrete and it shouldn't be reflective, let's go into the wall and turn down its matte specular. So it's much, much lower specularity. And change attributes to arguments. Resend our materials. Let's put this light directly off to the right. So there, we have a directional light coming from the right. So we also have an ambient light, and you can access the ambient light from any light, but I like to access it from my directional light. So it's ambient, and by default there is no ambient light, and ambient light is typically pretty low and pretty subtle, but just a little ambient light, just to give a sense that there's some reflectiveness in this space. There's some light bouncing off of things. So that's a good ambience. And maybe this diffuse is a bit too strong. take its brightness down a little bit. So the second type of light I want to look at is the spotlight. And of course, if we like this light the way it is, we should transform changed attributes to arguments. And if you want, you can go in and simplify these numbers just so this doesn't take up so much space. We don't need this look at. I don't know why ones come in as 0.99999. They are clearly meant to be ones. And ambient, we don't need all of these decimal points of accuracy. Nor with our diffuse. There, that's more compact and looks exactly the same. And we can get rid of our attrui if we're done with them. Now we have a nice compact programmed light. So let's make another one. And this one is going to be type spot. And we can immediately see what that does. And type spot has a bunch of attributes, but the first two attributes we'll look at are position and the look at. So like a camera, it doesn't just have a position in space. It also has something that it's pointed at. It has a look at point in the world. So if we move this light, right now it's at 111, which is the same place that our directional light was coming from. Position 111 means 1 meter to the right, 1 meter above, 1 meter towards the camera. And the default direction of our directional light was -1, -1, -1, which means the same thing as position 111. It means from the right, from above, and from the front. So if we move this light, we notice that it goes off of her, right? Because the look at does not change with the position. And this is the same reason why in our camera control unit here, we had to specify the look at each time in these messages, because the look at doesn't update unless we update it. So just by zeroing this look at back out, the light goes back onto the figure. Same thing. If I move the light up, it will eventually go off of my figure until I adjust the look at, and then it goes back down. And of course, the further away the light gets, the larger an area it covers. Right, as I move the light further away, it covers a wider area because it's a cone. And as I move the light closer, it covers a smaller area. There's the side view. There's the front view. Adjust the look at again. But there's another way to adjust the size of the light, which is by changing the spot angle. Oh, and we should turn on shadows here, because that obviously will give a much more dramatic and realistic effect. Shadows on. There. Now we're getting, that shadow makes the whole thing feel a bit more real. The spot angle is simply the size of the spot. And if we want to focus in on her head, we're going to have to move the look at up a little bit. And now we can see there's a circle of light that's just on her head. And we also, it doesn't have to be a hard-edged spot like this. In fact, most of the time, your spotlights are not hard edged like that. You also have the spot fall off. So let's make the spot bigger and give it some fall off. And we see how nicely it softens the edge, takes away that hard edge. So you want to combine your spot angle so that you don't blow the shadow out, but you also don't get the hard edge. Combine the spot angle with the spot fall off. But the thing to recognize is you can't utilize fall off with a tight spotlight. That's not going to fall off well. By the time you get the fall off, it's a very, very tiny area of light, and you have to crank the fall off way up. You want to make your spot area large and then use the fall off to get rid of the hard edge. And you get a very, very realistic spot effect. So this third type of light, we're not going to use it in this scenario. So let's transform change attributes to arguments. Get rid of my attrui. Command J to size this up. And if you want to, go back in, clean up these numbers just so they're more readable. This one's not bad, actually. Just a couple highly, highly specific numbers to chop down there. So the third type of light could apply in a situation like this, but it's much more for dealing with something like a solar system situation where you need a central light like the sun. The sun, in the case of looking at a solar system, is not a directional light because it's coming from the center and radiating out. So let's make some grid shapes. Now you might say, okay, where are these? Well, I made these 20 meters above our current scene. So even if I go to the top view here, I still can't see them. But if I were to zoom way out, there they are, 20 meters above our current scene. So I can just set up a new camera angle. So I'm going to make a new message. Look at 0, 20, 0. So basically look up. And put it on tripod. So look at 0, 20, 0, tripod 1, send that message, and now we're looking up at these two spheres I created. I'll make them bigger. And I'll give them a material. Use the same material on both spheres. We're getting some light from this light here, so I'm going to turn that light off because the directional light is still affecting these spheres. So I'm going to turn off the diffuse. And I'll turn off the specular. I'm putting these in a message box that then becomes a button when I lock the patch. I lock the patch, and there I've turned off the light. And you can see the ambient light is still functioning, and that's fine. So I'm going to move these a little bit further apart. And between them, I'm going to put a light of type point. Right, so we can see what a point light does. A point light radiates from its position out in all directions. So for instance, if I put another sphere here at position 0, 20, 4, right, they're all illuminated from this light that sits in the center of the three. And it can be handy to mark the position of that light There's a couple ways to see the position of a light. One is, and you can do this with any light, one is to draw bounds. You turn on draw bounds and it shows you where the light is. And that's cool. Turn on draw bounds while you're positioning a light. Let's change the position of this light. Right, as I move it around, the spheres are affected. But if you want something you could actually leave in your scene, you can just use a grid shape. Things are getting messy here, so I will encapsulate that. Command J to resize it, resend that message, turn off the directional light, and I'll encapsulate this. Okay, so now I have a little marker, which is where my light is. All right, and if I want it to move along with my light, I can attach the position attrui to both. And an attrui connected to two different objects will affect both objects. So I can move my sphere around and it will move my light as well. So it's a handy little light marker. And of course you can use multiple lights in a scene, and typically you will use multiple lights. Even here we've left a little ambient light on just so we can see the other side of the planets. If we wanted a starker effect here, we could go in, turn our ambient light off as well. And now we're getting only the effect of the point light on our three planets, which is more dramatic, but it's also harder to see what's going on. So that's a creative choice that you make, whether you want the ambient lighting in there or not. So that's a quick introduction to lighting. Hope that was useful for you.